This is Frank Yu, AP Physics math teacher. I have been teaching AP Physics over 11 years, and also I'm the founder of the Neighborhood Home Education, which is a online education community which try the best to help more students to overcome the gap between the top university and your current learning. And we have been successful. We help many students to take the AP exams, and we know where and how to get help to better prepare the exams. So I want to do a very quick demo to show how we can understand the AP Physics and how we can learn AP Physics C. So today I prepare the topic about AP Physics C. Some students ask me whether I can learn AP Physics and AP Physics C together. The answer is possible, especially you are taking AP Physics 1 and AP Calculus or Calculus course together. If you do so, you can treat AP Physics C as a application of calculus back into physics field. And some students want to know that how much grade that I can transfer my raw score on the paper into a grade system of 5. So I truly recommend you to this website, and on this website you can tap in your section 1 score, your scores of each free response questions, and then the system will automatically work out your predicted AP score according to your specific raw scores. That is really cool. Okay, and this chart shows you that how many percentage of the students can get AP score from 5 to 1. And please notice that if your score is below 3, it won't work for college application. So try your best to get as much grade as you can, at least above grade 3. Okay. All right. So let's try to work on a simple question to fill the AP Physics C. Okay, so let's check about this question. The force exerted by a screen when it is displaced by x from the nature lines and given by an equation fx equals to minus kx, where k is a positive constant. This equation is known as Hooke's law. What is the work done by a spring as it pushed out from x equals to minus x2 to x equals to minus x1? Okay, so suppose you meet this question just after you learn the concept about Hooke's law during your AP Physics 1 learning journey. So you know the basic formula of Hooke's law, which is Fx equals to minus Kx. And your teacher probably told you that, okay, the energy stored into such a spring system can be rewritten as the E equals to 1/2 kx squared. So that is the elastic potential energy stored in a spring at a certain extension point. So if you want to work out how much energy changed, or we can feel like what is the work done and what is the purpose of work done. So any work done may affect the changing energy, right? So it should be the knowledge we have learned in the AP Physics 1. So we combine those two formulas together. We can write in this way. So the work done equals to the change of energy, and which is 1/2 k x final squared minus 1/2 k x initial squared. And then you can work out the result. And also, you may learn that how to represent such a how to visualize such a change in energy. And then we can go back to the picture. So first, we set up a coordinate system with horizontal axis presenting the force and horizontal axis presenting the changing in direction, changing in length. All right. So then you will learn that the area below the fx curve with x-axis is representing the changing energy. Then you can transfer this question into this way. Okay. So if we can work out the area of the shadow or the area under the curve, which is just perfectly equals to the changing energy, and which is perfectly shows the work done. So we learn it. So you can see both of the result is matching. Okay. So far it is what we have learned in AP Physics 1. But some students, some really good students may ask, why we can create such a visualized method to work out the energy during a changing force with a constant changing rate. Okay, here is the key. A changing force, which means force is changing. But in this case, the force is changing with a constant rate. And some students may ask, because I frequently met the students ask me during the class, what if the changing of F does not having a constant changing rate? So which means the force Fx is presenting not a linear function instead of a curve or even a more complex graph, right? Then we'll use calculus to think about the question. Okay, so if we divide the whole area into many small slices or pieces, many pieces, and in that case, we can think that each small piece is just representing as a very small rectangle shape. So we know that the rectangle shape is easy to work out. That is the head times the base. Okay, so let's transfer these two variables into fx and x. So we use fx to represent the head, and because the base is really narrow, so we will use dx to represent the base. So this small slice, the area of this small slice equals to fx times dx. And because there are so many slices, and we have to add up all the slices, right? And which symbol in calculus that we can use to show the add up or the addition? We can use integration sign to represent such a adding up effect. And also we know that such adding up is from negative x2 to negative x1. So we give the lower bound and up bound, which is the minus x2, the minus x1. Here we go. Here we go. We summarize a formula of adding up all the changing in energy by the work done by using the calculus method. All right, here is the solution in AP Physics C. So the work done equals to the changing of the energy, which equals to the adding up the integration of fx times dx. And then because we know that fx equals to minus kx, So we use minus ks instead of fx input here. And from this method to this method is a very typical integration method, right? And it is not hard to get this result. And finally, we put the question cancel out the minus sign inside of the bracket with the minus sign outside the bracket as lower and up bound, and then simplify in this form and finally got the solution. So we can see that by using those three methods, we can share the same result. So which means those results, the result in AP Physics C by using integration can prove the result from the formula. Or we can think in this way, many formulas we have learned in AP Physics 1 is just a conclusion deduced by using calculus method. Alright, so if you need more help or if you have further questions, please feel free to contact us. Thank you for your time.